All right, here's the Chapter 3 practice test for finite math. The first one here, we're going to write out the constraints and the variables, and then we're going to graph it and show the feasible region for this situation. Number 1, so we say x is, what is x? Make sure, let's see, the manufacturer two kinds of baking dishes. So X is the number of the two kinds of baking dishes. And they're in two price categories. So it's the number of $4 dishes, and Y is the number of $6 dishes. So the description of the dish is by money instead of saying it's a casserole dish or a baking dish or whatever. So the money tells us what kind of dish it is. All right, we only have $8,000 to spend. So we have to be less than or equal to $8,000 per week. So do not exceed $8,000. So whatever we put over here has to be less than or equal to 8,000. And then we just say X is the number of the $4 dishes. So 4X would be all the dishes. It would be the money for the $4 dishes, and then 6Y would be the money for the $6 dishes. So that's the only equation. We're just restricted to money, just one restriction. And of course, X has to be greater than 0, and Y has to be greater than or equal to 0. So I'm just graphing this part right here. I'm going to do the diagonal 0 trick because that lets me know kind of the extremes of the situation, so I can know what I need to do here. If Y is 0, that disappears. So 4 times something is 8,000. Well, 4 times 2,000. And then X is 0. 6 times something is 8,000. So I get out the calculator here. And I got to do 8,000 divided by 6, which is 1,333 and 33. So it's 1,333.3 repeating. So I can do 2,000 of the $4 dishes, or I could do the 1,333 of the other dishes. So I'm going to count by I can count by 200s, which would be 10 spaces. So 200, 400, 600, 800, 1,000. So that'd be 1,000. 200, 400, 600, 800, 1,000, that'd be 2,000. So 2,000 is right there, 2,000, 0. And then 200, 400, 600, 800, 1,000, so there's 1,000. 200, 400, 600, 800, 2,000. So 1,200, 1,400, 1,333 would be about there. So then these are going to connect together. We're going to be greater than 0. We're going to be greater than 0 this way. So I've just done this triangle right here. I'll get out a marker. So here's the triangle. So this is the only thing I can do. The different kinds of dishes that I can make have to be there. Write the inequalities that express it for me. Make sure to include the variables represent. And there it is. So the extremes of the situation are 2,000, 0, 0, 0 would be making no dishes, and then 1,333 and a third dishes this way. Whoops, it'd be 0, that. Can't really make a third of a dish, it has to be in whole numbers, but anything up in there would be an extreme. Okay, the next one here, we're just straight up graphing, and we're going to shade the appropriate area. So do the blue equation first. This would be 0, 5, and then 5, 0, because 5 plus 0, 0 plus 5. Those are the two extremes there. So you go 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So there's the first line. And it says X plus Y is less than 5. So 0, 0 would work on this. So I know that I'm going to shade underneath of that because it's 0 plus 0 is less than 5, which is down here. So it's everything below that. Then I guess I'll do the red equation next. So I'll put a red dot here. And the diagonal zero trick just kind of lets you know kind of what kind of scale you need, because obviously I wouldn't want to count by ones on that one, would I? So 0 goes in for x, 2 times something. Well, how about 6? That makes 12. That's a 0, not a 6. And then 0 goes in for y, so 3 times 4. 3 times 4 makes 12. So 0, 6 is one space up there. 4 zeros be one space in there. So it's going to look like this. And 0, 0 also works in that. So I'm shading underneath this one too. So I'm shading underneath the blue line, and I'm shading underneath the red line. So this is the area, the area that works for this. I'll extend this blue line all the way out to the edge of the graph, and I can extend this red one out to the edge of the graph there. If I want to make it prettier, I would use a ruler. This works for general explanation. So I'm under the blue line, under the red line. So it makes this x, but this is the area that's true. That's the area that makes both equations true. Grasp the system inequalities. List the corner points of the feasible region. All right. So if you look on the answer key, I counted by ones, and I started about in here. So I made this the y-axis, and then across this way, I made it the x-axis. And it's in the first quadrant, right, because it's greater than or equal to 0 on each one of them. Okay, so this one is 0, 6, 6, 0, like we just did with the 5. So it's 0, 6, 6, 0, because 0 plus 6, 6 plus 0. So 0, 6, 6, 0. And 1, 2, 3, 4, 5, 6. There's 6, 0. And then 1, 2, 3, 4, 5, 6. Did I get it? 1, 2, 3, 4, 5, 6. Sometimes my eyes get crossed up. So that's this one. Okay. Then the next one would be right here. 0, 0. So it would be what? 4. If x is 0, it would be 4. And then 8. So 0, 4, 8, 0. So that's 6, 7, 8. And then that's 8, 0. And then 0, 4 would be 1, 2, 3, 4 right there. So that's down 4 and over 8. So it's a slope of down 1 over 2, down 1 over 2. So that's nice, down 1 over 2, down 1 over 2. So if I put some extra dots in there, then I can get that intersection point. So I know one of the intersection points is right there at 2, or 4 over up 2. Okay, now we're going to put the last line in, this one here. And 0 goes in for x, so it'd be 2 times 10. And 0 goes in for y. And we get 7 times, so it'd be 27s. 27s. 27ths is almost 3, just a little bit less than 3. So we go up 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 27ths is just a little bit less than 3. If you found the slope, if you look on the answer key, I actually found the slope. The slope is negative 7 over 2 on the answer key. So you could go down 7, 1, 2, 3, 4, 5, 6, 7 over 2, 1, 2. So it's going to intersect right there. And then down 7, 1, 2, 3, 4, 5, 6, 7 over 1, 2. And it goes right there, because it's a little bit less than 3. So it comes down like so. All right, and then you check it out, and it has to be below these two slanty lines, but it has to be above this line. It has to be greater than the 20 line. Because 0, 0 works in the first two, so it'd be below those, but 0, 0 doesn't work in this one, so it'd be above that one. So that's the region right there. And this point right there is easy to see because it's just over 4 and up 2. We talked about that already. This was at what, 6? Yep, 6, 0. This one is easy to see too, 2, 3. 2, comma 3. And this one we know is 27, 0 because that's where the intercept is. So it's over 27, comma 0. Okay, so there are the points right there. All right, the next problem is just making the table. So this is part of it, right? It's making the table x and y and z is equal to 4x plus 5y. And you just put the points in. There's only 3, 1, 2, 3. You just put them in there. You put 30 there, and 0 there, you get 150. And 15, and you put 15 there and 12 there, put it in the calculator, you get 120. And then 4 times 26 is 104. And it wants to know the minimum. The minimum is 104 when it's 26, comma 0. All right. Number 5 is just part of it, where you're defining the variables and you are writing the objective function, you're writing the constraints, but you're not solving it out because I didn't leave enough space for that. So do not solve, just define your variables. So we got x is the number of, y is the number of, and we're selling two things or making two things. We're making, what are we making here? We're making suits. A suit requires, and we're making a dress. So it's the number of suits, and it's the number of dresses. Okay, and we're restricted to the amount of cotton we have, so we have to be less than or equal to 80. And we're restricted to the amount of wool that we have. And of course, we're making positive, only positive numbers of suits. So x is greater than 0, y is greater than 0. So we read through it again. We only have 80 and we only have 20. A suit requires 2 yards of cotton. So that's going to be 2x, and a dress is 1 yard of cotton. So 1y. Or you could just put y. Then we're limited to the amount of wool that we have. So we have amount of wool we have. So the wool is dress requires 1 yard of cotton and 3 yards of wool. So wool for 3, that'd be 3y. And then a suit is 2 yards of cotton, but 1 yard of y, so 1x here. So that would be it. So it's 1, this is wool. I'll put wool here so I can read it better. And this is cotton. So a suit requires 2 yards of cotton and 1 yard of wool. No, that's not right. 2 yards of cotton for a suit, 1 yard of cotton for a dress. So this is the cotton equation. This would be 1 yard of wool for a suit, 3 yards of wool for a dress. Yep, a dress requires, so it's 1 and 3, 2 and 1. And there it is. All right, I have to stop this.